Hi, this is Mr. McDowell coming to you in your home with your video notes for Lesson 2.5. I hope you have your notes template. Lesson 2.5 is about solving equations that have variables on both sides. Vocabulary that I want to key in and make sure we're clear on is what are like terms, and like terms are terms that have the same variable and they must be raised to the same power. The key thing about like terms is they can be combined. If we drop down here, there's another special type of terms to consider, and they are called constant terms. And I think we've talked about these, but constant terms do not have a variable, therefore their value can't change and they will stay the same no matter what, or constant. And these terms are also supposed to be or should be considered like terms. If we drop and take a look at the first example that we have, it's probably the hardest one that you'll have because of this fraction right here. You could distribute it or you could do something else. When I make the decision if I want to distribute it, I consider that there's a 3 on the bottom, and that would be a number I'm going to divide by. Both the 6 that you see here and the 15 that you see there are divisible by 3. So if we multiply and distribute this in now, we're going to do the 6 divided by the 3, and then we're going to multiply it by the 2 that's on top. So 6 divided by 3 is 2 times 2. This turns into 4y. The 15 divided by the 3 times 2. When you divide 15 by 3, you get 5, plus the 2 times the 2, you get 10. And now we've distributed the 2/3 in rather than getting rid of it, which is another option. But I'm not going to do that here on this one. Now, normally we would have looked at this, and don't write down what I put in yellow, please. But we would probably look at it and say the -6 and the +10 are like terms, but they're on opposite sides of the equal sign. To get them together, we should add 6 to this side and add 6 to this side. That would eliminate it on this side. That's one option that we could do. But we also could have, if we had wanted, we could go through and we could subtract 10 from this side and subtract 10 from this side. That'd be another option, and we would eliminate it on that side. But I want to emphasize to you that's really doing nothing more than combining like terms that are on opposite sides of the equal sign. So now if you go back to writing with me, we want to consider that the 8y and the 4y are really like terms. I would like to subtract the 4y from this side, because by doing that, I end up with a positive number over here on the left side. By combining the 8y and the -4y, I am left with 4y minus 6 equals, this is eliminated, and the only thing we have over there is 10. At this point, it's a two-step equation that we've practiced and been working with. We should add 6 to both sides. After adding 6 to both sides, the equation becomes the equivalent equation of 4y is equal to 16, and the result of that needs to be divided by 4 on both sides to get the answer, so that we can have 4 divided by 4 turn into 1. 1 times y is y, and the only thing we have left on the right side is y, and y equals 4. At this point, for example 2 over here, I would like to have you pause the video and do it on your own. Welcome back. I assume you've completed it. I'm going to go through and quickly show the results of what you should have got. You should get 6z minus 6 here is equal to 5z minus 2. From here, I would probably end up subtracting 5z from both sides. By subtracting 5z from both sides, that allows me to keep a positive coefficient or positive value with the z. This is a positive 1z. I would rather, instead of writing 1z, just leave it as z minus 6 is now equal to, and on the right side I bring down the -2, and from here I would add 6, get now 4 equals z, and there's my answer. We look at the other two examples that we have. Please note on example 4 over here, I actually have a typo, and I had 3 times a plus 2. I really want that to be 3 times 2a plus 2. Sorry about that. If we go through solving these and I distribute here, I'll get 9z plus 27 is equal to 9z plus 12. And you could get your constant terms together first, but this is why I like getting the variable terms together first. If I subtract 9z from both sides, that will eliminate it here, and I will get 12 equals, And the 9z minus 9z over here gets me 0z, which is really eliminating this as well. So instead of writing in the 0z, I would just know that, I have my equal sign, that this is eliminated, and the only thing to bring down is 27. Now when your variables eliminate each other and they disappear, you end up with an equation that is a false statement, that 12 does not equal 27. This solution, or this equation, has no solution. It's a special case of an equation that cannot be solved and have a solution. If we go over to the other example that you have, when we distribute the 3 to the 2a, we get 6a. With the 3 times the 2, we get plus 6. That equals, on this side now, when we distribute, we get another 6a, and we get plus 6. And if we combine these like terms by subtracting 6a from both sides, we'll see that 6a eliminates, and on this side we bring down the 6. We bring our equals down. The 6a minus 6a here again gives us 0a, which basically eliminates, and we bring down the 6. So here's a different situation where our variables disappeared or eliminated on both sides, but this statement that we have right here is a true statement, and this ends up being identified as called the identity. And what it really means is that all real numbers are the solutions. Can't spell real, I guess. All real numbers are the solutions. But what I would like you to be doing is the book wants you to learn and call that the identity. If you look up here, the one side over here has the exact same identity as the side over there, and that's a little bit of how it gets the name the identity. But please go to where you eliminate the variables. Well, that concludes your video notes that you have for this, and we will see you tomorrow in school.